Hello everyone. Today I am going to discuss the quick problem of AtCoder beginner contest 314, which is Roulettes. So we are given in wheels, Roulette wheels. Each wheel will have pi number of integers written in it, si1 to si pi. And when we choose a wheel, in each turn we will choose a wheel. When we choose the ith wheel, an integer j between 1 and pi inclusive will be chosen at random, and we will earn sij points. Okay. Now Takashi wants to earn at least m points, and when we are using one wheel, we have to pay the cost of CIN. So Takashi wants to earn at least m points, and what he tries to do, he tries to minimize the amount of money he pays before he earns these m points. Okay. So let's go through the one of the example. Let's take this example. uh, this is the example. So what is it? So we are given three roulette wheels. The first number is the cost of choosing the first wheel, second wheel, and third wheel. And there are two integers written in the first wheel, 5 and 9, and there are four integers written in the second wheel, and there are five integers written in the third wheel. Okay. Now what you can do, or Takahashi can do, is that he can choose one wheel, and uniformly at random any one of these two integers will be chosen, and he will earn 5 or 9 points. Okay. If he chooses the first wheel, and one integer between 5 and 9 will be chosen, and he will earn either 5 and 9. But for choosing this wheel, he has to give 100 amount of yen. Okay. So at the end, he tries to get at least 14 points, and he wants to minimize this value. So there are two variables here. The first variable, let's say variables. The variables, first variable will be the points. First variable will be the points, and the second variable will be cost. Okay. So when he is choosing the first wheel, he has to pay cost CI, and he will earn anything from SI1 to SIPI. Okay. I hope you got it. This is the problem, and I hope you know what is the expected number of points, or expected number as a general concept. Here you can read the more formal definition. I am not going into the details. So let's jump into the solution idea. So the first thing to observe here is that the constraint on n and m, the constraint on n and m are quite less. You can think about order of n into m, or order of n into m, n square m type of solutions. So for this, we can choose this value, or m is the initial value, or initial number of points. You can say initial number of points, let's say, equals to 0. Now you want to make this coin. This is the number of points. You want to make this value to m, so you want to make a journey from 0 to m, or what I am doing here is that I am taking the reverse way. I am going from m to 0. Both are similar. So initially, let's say our points are m, and when we are choosing some integer, our value of this the number of points, let's say this is one variable, the number of points will decrease from m minus sij. Okay. M minus sij. And so let's say we have chosen the first wheel. So there are p1 number of integers written in the first wheel. So the probability of choosing any of one of the integer will be 1 by p1. Okay. So our probability is nothing but 1 by p1. So when we are choosing some integer 1 by p1, we are doing some, let's say these are the recursion state. So let's say these are recursion state. The first value I am taking is the number of points. Okay. Currently we have m points, and when we are taking some value from some of the wheel, the value of point will decrease by s minus j. Sorry, m minus sij. So when we are choosing some value from the first wheel, our value of the recursion will be nothing but 1 by p1 minus rake of our current points, let's say val, minus p1j. Okay. We have to take summation of all this. Okay. And after that, this is not probability, you can say this is our desired value. Okay. Probability is 1 by p1. Actually probability is 1 by p1, and when we are choosing the first wheel, our probability value will be 1 by p1, and for every value in the wheel we are doing value minus p1j, and at the end for choosing the this wheel we have to add the cost of choosing this wheel, let's say c1. Okay, so this is the cost of choosing the first wheel, okay, for the given number of points. Okay, so let me clear it out again. So let's say this, our let's say our value of dpi val, I is the number of wheel, is nothing but zero, sum of 1 by p1 into recursion of value minus p1j. So we are taking sum over j and plus c1. This is the value of dpi val. Now what will be the value of dp val? Dp val is nothing but dp val will be nothing but minimum of dpi's, dp val i's or dpi vals, you can say. As I have written dp I val, so I will write dp val equals to nothing but minimum of dpi vals. Okay, sorry, yeah, dpi val. Okay, so I hope you got it, this thing. Okay, so at any value, at any value of points, what we will do, we will try to take minimum of all the roulette wheels. Okay, so that is the catch here, but there is one more problem, that is the value could be 0 also. In the second example you can check is that the value could be 0 also. So when we are doing some recursion, let's say we are at some value rake of val. Now we can't go back to rake of val again if we are choosing 0, because this is the transition for the recursion val minus p1j, but when p1j is 0 we can't go back to p1j. Okay, sorry, rake of val. So let me clear this thing and try to explain again. So what is happening when we are choosing some value 0, we are going back to the same recursion step. So let's say our value of dpi val, so let me write it in text format. So dpi val will be nothing but I have written the formula here, sum of 1 by p1, this is nothing but sum over 1 by p1, uh, sorry, 1 by p1 into rake of val minus p1j, sorry, a1j. Okay, so now for some of the values a1j will be 0, so let us take separately, or we can say plus number of zeros, let's say 0 zeros by p1 into rake of val. We can write that, right? We can write that because rake of val minus zeros will be val plus cost. So if we take this thing, if we take these values of zeros by p1 to the left hand side, so we what we'll have, we'll have p1 minus zeros by p1 into dpi val. But rake val is nothing but dpi val, right? Because when we are taking this thing, for this you have to observe is that we are taking this roulette wheel once, so for the next turn we will take this roulette wheel again, because else there will be no way we will choose, because we are minimizing the value now. So if we take this wheel, that this wheel will be the minimum value, in the second turn we have to take this because we have already assumed that this is the minimum value. So p1 minus z by p1 into dpi val will be nothing but this formula. Okay, and at the end we have to multiply, for getting dpi val we have to multiply it by this thing, inverse of this thing, which is nothing but p1 by p1 minus z. So let us go through the code now. So here I am taking ci as cost I, and here aij. Now what I am doing is that I have already told, instead of going from 0 to m, I am going from m to 0. You can do this thing also. So if you want to go from 0 to m, you can call rake of 0, and when we are adding val minus aij, instead of that you can do val plus aij, and this condition will also get reversed. It will be val, if val is greater than equals to m, return 0. So this is the memorization part, or base condition, you can say. Now this part is the main part of the problem, or the transition state of the recursion. So what is it happening? I am counting the number of zeros in each roulette wheels. Okay, If ai is equal to 0, then I am incrementing the values of value number of zeros, count of zeros you can say. Now race is nothing but race plus rec of val minus aij, and our probability is 1.0 by pi. I have already told you that probability value is this thing 1 by pi. And so we are instead of multiplying everything by 1 by pi, we can just calculate the sum of the things and then multiply it by 1 by pi. Okay, I hope you got it. So instead of taking the summation here, we can take 1 by pi out of the summation and do take of this thing. Okay, I hope you got it. So that's what I have doing here. I have taken the sum of the races first, and at the end I am multiplying it by probability plus the cost I. Now if the number of zeros are greater than zeros, the count of zeros are greater than 0, then we are multiplying it by this thing. Where I have written, yeah, pi minus z by pi. Okay, this is nothing but pi minus z by pi. Okay. And at the end I am taking minimum of answer comma race. For race is nothing but dpi value here, and for every roulette wheel we are taking the minimum value to answer comma race. Okay, and at the end we are returning the answer. I hope you got it. If you have any doubt in any part of the explanation, you can write in the comment section. I will try to reply each and every comment. I will also provide the link of the code in the description box. Please like the video and subscribe to the channel if you find this helpful. Thank you.